Ladies and gentlemen, let's take a journey back to a time when the world looks up at the sky with wonder and curiosity. A time when reaching the moon was not just a dream, but a goal that captured the imagination of millions. In the 1960s, the space race between the United States and the Soviet Union was more than a scientific competition. It was a symbol of technological supremacy, national pride, and the promise of human achievement. The idea of stepping onto another celestial body had fascinated scientists and writers for centuries, from the earliest telescopes to science fiction novels that imagined humans walking on the moon. By the mid-20th century, the launch of Sputnik by Soviet Union in 1957 sent shockwaves through the United States. Suddenly, the race to space was real, and America had to act fast. The goal was ambitious, even audacious, to send humans to the moon and bring them safely back to Earth. President John Kennedy set the tone for this mission in 1961. He challenged the nation with a bold promise, stating that America would commit itself to landing a man on the moon and returning him safely to Earth before the decade was over. It was a call to action, not just for scientists and engineers, but for an entire generation of Americans who would dedicate their lives to turning this dream into reality. This was the beginning of Apollo, a series of missions designed to explore space and ultimately achieve a moon landing. The program faced enormous challenges. Technology capable of sending humans 200,000 miles away and bringing them back safely did not yet exist. Rockets, navigation systems, life support equipment, and communication networks had to be invented, tested, and perfected. Every step was a risk, and every experiment could have ended in failure, but it was not only the engineers and astronauts who made the mission possible. Thousands of people across the United States, working in factories, laboratories, and mission control centers, played a crucial role. Each bolt, each calculation, and each test contributed to what would become one of the greatest achievements in human history. The Apollo program became a symbol of what humanity would accomplish when curiosity, determination, and teamwork came together. So, as we begin to explore the story of Apollo 11, remember that it was not just a mission of machines and astronauts. It was a mission of dreams, a mission that reflected the hopes and fears of an entire world looking toward the moon. It was the moment when science met courage and imagination met reality. Now, let's step behind the scenes and see how Apollo 11 went from an idea on paper to a mission ready for launch. Preparing for a journey to the moon was not something that could be done overnight. It required years of careful planning, testing, and training. Every detail mattered because once astronauts left Earth, even the smallest mistake could become fatal. NASA selected three astronauts for Apollo 11: Neil Armstrong, Buzz Aldrin, and Michael Collins. Each of them had already proven themselves as highly skilled pilots, engineers, and problem solvers, but no amount of previous experience could truly prepare them for walking on another world. They underwent intense training for months, learning how to pilot the lunar module, perform experiments on the moon's surface, and even survive in the harsh conditions of space. Simulators played a key role. These were not just the basic mock-ups, they recreated the exact conditions of spaceflight and the moon landing. Astronauts practiced countless scenarios, including emergency landings and equipment failures, to make sure they could respond calmly under pressure. Every movement they made on the simulator had to be precise because the real moon offered no second chances. Meanwhile, engineers and scientists worked on spacecraft itself. The Saturn V rocket, which would carry Apollo 11 into space, was the most powerful rocket ever built. It stood taller than a 36-story building and had the strength to lift more than 100 tons into orbit. Building it required solving problems that had never been encountered before: engines that could produce millions of pounds of thrust, fuel that could survive extreme temperatures, and guidance systems that could navigate to the moon with extreme precision. The lunar model, which Armstrong and Aldrin was used to descend to the moon, was another engineering marvel. Lightweight but sturdy, it had to land safely on a surface no one had visited, then take off again to return the astronauts to the command model orbiting the moon. Everything had to work perfectly together, from the rocket to the spacecraft's tiny thrusters. But preparing for Apollo 11 was not just about technology, it was also about understanding the moon itself. Scientists studied photographs from earlier unmanned missions, learning about craters, dust, and the challenges the astronauts would face when walking on the lunar surface. Every step had to be planned, every experiment carefully considered. This preparation was immense, global, and detailed. Engineers, scientists, technicians, and astronauts worked together as one team with a single goal: to put humans on the moon and bring them back safely to Earth. The combination of human determination, technological innovation, and meticulous planning set the stage for a mission that would become a defining moment in history. Picture this. It is the morning of July 16, 1969, at Kennedy Space Center in Florida. The air is thick with anticipation, and the gigantic Saturn V rocket stands tall on the launch pad, a symbol of human ambition and technological power. This rocket is the most powerful ever built, stretching over 360 feet high, and it carries not only 3 astronauts, but the hopes of an entire world. People have come from miles around to watch, their eyes glued to the towering machine, unaware that they are about to witness history. Inside the aircraft, Neil Armstrong, Buzz Aldrin, and Michael Collins are strapped tightly into their seats, checking their systems and running through countless checklists. Every instrument, every switch and wire has been tested hundreds of times, yet the risk is immense. They are leaving the only home humans have ever known, venturing into the vacuum of space where a single mistake could be fatal. NASA engineers and controllers are monitoring every moment from Mission Control in Houston, tracking trajectory, fuel consumption, and life support systems. As the countdown hits 0, the Saturn V ignites, producing a roar and flames so powerful that the ground shakes beneath the observers. The first stage between 20 tons of fuel per second, and within minutes, the rocket has cleared the atmosphere. The astronauts experience weightlessness for the first time, floating in the cabin as they prepare for the next critical maneuver, the translunar injection. This maneuver is essential to place Apollo 11 on its precise path toward the moon. The accuracy required is extraordinary, miscalculated by even a fraction of a percent, and the crew could miss the moon entirely. During this stage of the flight, the astronauts face both technical challenges and psychological pressure. They are isolated, thousands of miles from Earth, moving at speeds over 24,000 miles per hour, and entirely dependent on the spacecraft and ground support. They maintain constant communication with Mission Control, providing updates on fuel, trajectory, and spacecraft systems, while also managing their own stress. This journey is not just a physical passage through space, but a test of endurance, focus, and teamwork. As Apollo 11 approaches the moon, its stark gray surface becomes visible through the windows, detailed and alien. Michael Collins prepares for his first role in orbit, while Armstrong and Aldrin ready the lunar module for descent. This moment is both exhilarating and terrifying. Landing on the moon has never been attempted before. The crew must navigate unknown terrain, deal with the lunar gravity, and manage complex systems while under the scrutiny of the entire planet. The journey to the moon represents a remarkable achievement in human history, combining decades of scientific research, engineering innovation, and the courage of astronauts willing to face unimaginable risk. It demonstrates that with careful planning, teamwork, and determination, humanity can reach beyond the boundaries of Earth and achieve the seemingly impossible. Every calculation, every action, and every decision made during this journey would ultimately decide whether humans could walk on the moon and return safely to Earth. July 20, 1969 is a date that will live forever in human history. After days of travel and complex maneuvers, Apollo 11 approaches the moon. The lunar model, named Eagle, separates from the command model, where Michael Collins remains in orbit. Neil Armstrong and Buzz Aldrin now face the most dangerous part of their journey, landing on an alien surface with no room for error. As Armstrong pilots Eagle, the module begins its descent into the Sea of Tranquility. The terrain below is rough, filled with craters and boulders. Mission Control watches anxiously as fuel levels drop. Armstrong makes a critical decision, taking manual control to steer the model away from a field of large rocks toward a safer landing site. The tension is palpable. For millions watching on television, every second is suspenseful. Finally, with just seconds of fuel remaining, Eagle touches down. Armstrong's calm voice is heard over the radio. Houston, Tranquility Base here. The Eagle has landed. The relief is immense, but the mission is far from over. The astronauts must now prepare for humanity's first steps on another world. When Armstrong descends the ladder and places his boots on the lunar soil, he utters words that echo through time. That's one small step for man, one giant leap for mankind. This step is not just symbolic. It represents culmination of years of scientific research, engineering innovation, and the human drive to explore. Buzz Aldrin joins him, and they together conduct experiments, take photographs, and collect lunar rocks to bring back to Earth. The moon is an alien world. Gravity is only 1/6 of Earth's, so every movement requires careful balance. Dust flows in slow arcs. Sunlight casts sharp shadows, and the horizon appears closer than it does in Earth. The astronauts plant the American flag, leave a plaque honoring those who have contributed to space exploration, and transmit live video back to Earth. Millions of people watch in awe as humans walk where no one has gone before. Every action on the moon is meticulously planned, but an unexpected challenge arises. The astronauts must manage limited oxygen and power, navigate the rough terrain, and avoid contaminating their samples. Yet their success inspires the world, proving that human curiosity and ingenuity can overcome extraordinary obstacles. The lunar landing is more than a scientific achievement. It is a symbol of international attention and cooperation, a triumph in the space race, and a defining moment of the 20th century. Armstrong and Aldrin return safely to the command module, and Michael Collins, who has remained in orbit, greets them with immense relief. Together, they begin the journey home, carrying the evidence of human capability to explore beyond our planet. After days on the moon, the astronauts must leave the lunar surface and begin their journey home. The ascent from the moon is delicate. Neil Armstrong and Buzz Aldrin lift off in the lunar module's ascent stage, leaving behind the lower portion in the moon. Michael Collins, still orbiting above, waits patiently in a command module, ready to rendezvous. Precision is crucial. Any miscalculation could strand the astronauts on the moon or leave them drifting in space. But the process was successful. Armstrong and Aldrin dock with Collins, and all three transfer into the command module for the return trip to Earth. As they travel back, they face new challenges. Re-entry into the Earth's atmosphere is intense. The command module must survive extreme heat, friction, and gravitational forces. The spacecraft shakes violently as it plummets through the atmosphere at thousands of kilometers per hour, but the heat shield holds, and the capsule slows safely. Finally, Apollo 11 splashes down in the Pacific Ocean, greeted by recovery teams from the U.S. Navy. They take precautions to ensure that no unknown lunar microbes contaminate Earth. The world celebrates their safe return with parades, speeches, and media coverage that captures the global attention. The aftermath of Apollo 11 extends beyond celebration. The samples brought back from the moon are analyzed extensively, providing insights into the moon's geology, formation, and history. Scientists discovered that lunar rocks are older than most on Earth, helping to confirm theories about the early solar system. The mission also drives technological advancements on Earth. Materials, science, computing, telecommunications, and engineering all benefit from innovations developed to support the mission. Politically and culturally, the mission boosts American prestige in the Cold War. The moon landing demonstrates not only technological prowess, but also the determination and capability of a nation committed to scientific exploration. It inspires generations of scientists, engineers, and ordinary people to imagine what is possible when humans work together towards a bold goal. Astronauts themselves became international heroes. Armstrong, Aldrin, and Collins traveled the world on a goodwill tour, sharing their experiences and encouraging interest in science and education. They face new responsibilities as symbols of achievement, resilience, and courage. Their mission, once a daring adventure, now serves as a lasting testament to what can be accomplished through planning, teamwork, and unyielding curiosity. The success of Apollo 11 sets the stage for future missions. It proves that landing on another celestial body is achievable, paving the way for subsequent Apollo missions that further explore the moon, conduct experiments, and test long-duration spaceflight techniques. The mission's legacy continues to shape human space exploration today, reminding us that exploration is a defining trait of humanity. Apollo 11 was far more than a moon landing. It reshaped science, culture, and humanity's self-image. The lunar rocks and soil collected revealed that the moon formed from debris after a colossal collision with Earth, revolutionizing a theories of planetary evolution. Experiments left on the surface uncovered moonquakes and heat data that deepened understanding of the moon's structure. Culturally, the televised moonwalk united millions in awe. Neil Armstrong's one small step became a symbol of human courage and potential, inspiring generations in science and engineering. Artists and thinkers reflected on humanity's pace in the cosmos and the fragility of Earth, while politically, the mission showcased U.S. innovation and determination during the Cold War. The lessons of Apollo 11 still guides modern exploration from NASA to SpaceX, proving that curiosity and collaboration can propel humanity beyond what once seemed impossible for us.